Hello, this is Santosh Shinde, IT Department, VP KBIT Baramati. We are talking about cloud security, and this is third part of this cloud security session. What we had seen in the first two parts is we had seen encryption and hashing techniques in the first part, and we had seen PKIs and digital signatures in the second part. Now this is the third part of cloud security video session, and in this we are going to talk about identity and access management, single sign-on, and hardened virtual server images. These are the three concepts we are going to cover in this cloud security part 3 video. So let's begin with identity and access management, IAM. Basically, the IAM mechanism, identity and access management mechanism, encompasses the components and policies necessary to control and track user identities and access privileges for IT resources, environments, and systems. Specifically, IAM mechanisms exists as a systems comprised of four main components. So there are four main components of IAM. So let's talk about them one by one. The first is authentication. So here username and password combinations we use generally for authentication. Username and password combinations remain the most common forms of user authentication credentials managed by the IAM system, which also can support digital signatures, digital certificates, biometric hardware like for example your fingerprint readers, and there are many other biometric systems like face recognition, nowadays iris recognition, and many more. Face recognition, specialized software such as voice analysis programs, and locking user accounts to registered IP or MAC address. So this is authentication, the first and foremost important component of identity and access management, IAM mechanism. Second component is authorization. The authorization component defines the correct granularity for access controls and oversees the relationships between identities, access control rights, and IT resource availability. We're continuing with the four main components of IAM. The third one being user management. Related to the administrative capabilities of the system, the user management program is responsible for creating new user identities and access groups, resetting passwords, defining password policies, and managing privileges. So this is all about user management, managing their groups, resetting their passwords, changing passwords, defining password policies, and managing the privileges. Like users will have read access, some of them will have read write, and like that. So managing their privileges. Credentials management. The credential management system establishes identities and access control rules for defined user accounts, which mitigates the threat of insufficient authorization. The IAM mechanism is primarily used to counter the insufficient authorization, denial of service, and overlapping trust boundaries threats. The second important and very interesting topic in cloud security is single sign-on. So you need not have to do signing on multiple times. You are using the systems. So single sign-on. Once you sign on, and you get access to everything. Propagating the authentication and authorization information for a cloud service consumer across multiple cloud services can be a challenge, especially if numerous cloud services or cloud-based IT resources need to be invoked as a part of the same overall runtime activity. So you wanted to gain an access to numerous cloud services and so many cloud-based IT resources. Every time you are doing a sign-on, which is basically can be avoided using single sign-on mechanism. So the beauty of this single sign-on mechanism is that it enables one cloud service consumer to be authenticated by a security broker. So there is someone, a third party maybe sometimes, which is acting as a security broker, which will authenticate you once, which establishes a security context that is persisted while the cloud service consumer accesses other cloud services or cloud-based IT resources. So you need not have to again and again authenticate yourself for every cloud service that you are accessing, or for every cloud-based IT resource that you are going to use. So otherwise, in other words, we say the cloud service consumer would need to re-authenticate itself with every subsequent request, and those efforts are being saved with single sign-on mechanism. The SSO mechanism essentially enables mutually independent cloud services and IT resources to generate and circulate runtime authentication and authorization credentials. So here you can see that there is a cloud service A and cloud service B and cloud service C. You are going to use multiple cloud services, and there is something we have just talked about, the security broker service, which will take care of your security credentials and giving you a security token and authenticating you. And this will be a one-time authentication, and subsequent accesses to all cloud services could be done seamlessly. A cloud service consumer provides the security broker with login credentials. So a cloud service consumer unit is going to provide the cloud security broker with all the login credentials, security credentials. The security broker responds with an authentication token. That is a message with small lock symbol upon successful authentication, which contains cloud service consumer identity information. Now, using this, that is used to automatically authenticate the cloud service consumer across cloud service A and cloud service B and cloud service C. Otherwise, what would happen is the consumer has to do it separately with cloud service A, re-authenticate itself with cloud service B, and again for cloud service C, and all for subsequent such requests it has to do so. So all those efforts are saved here, and that is the beauty of single sign-on. Here is an architecture. The credentials received by the security broker. This is a security broker service, and it is receiving the credentials from cloud service, cloud resource administrator. So the credentials received by the cloud security broker are propagated to ready-made environment. So there is a, you can see here there is a ready-made environment A provided by cloud A, and there is another ready-made environment B provided by cloud B. So the credentials received by the cloud security broker are propagated to ready-made environments like environment A and B across two different clouds, cloud A and cloud B. The security broker is responsible for selecting the appropriate security procedures with which to connect to contact with each cloud. So this is an interesting topic, single sign-on. And the last among the bunch of topics that we had talked about cloud security, last but not the least, is hardened virtual server images. So let's see what it is conceptually. Previously discussed a virtual server, as previously we have already seen what is a virtual server. A virtual server is created from a template configuration called a virtual server image or virtual machine image. Hardening is the process of stripping unnecessary software from a system. You are cutting down unnecessary software components from a system, redundant components maybe we can say from the systems, such that you limit the potential vulnerabilities that can be exploited by the attackers. So you're trying to reduce it. Hardening is thereby a process of let's see again stripping unnecessary software from a system to limit potential vulnerabilities that can be exploited by the attackers. So only required part in a very short way you are passing or you are transmitting. Removing redundant programs, this is how we do it. Closing unnecessary server ports which are not required, and disabling unused services not in use nowadays, and internal root accounts and guest access are all examples of hardening. So we all remove such things such as redundant programs, unnecessary softwares are to be stripped up, closing unnecessary server ports and disabling these unusable services, internal root accounts and guest access are all these are all examples of hardening. And we remove all these and try to make it as shorter as possible so that it is less vulnerable for external attacks or attackers. A hardened virtual server image is a template for virtual service instance creation that has been subjected to a hardening process. We'll see the hardening process in the next slide in figure 10.13. This generally results in a virtual server template that is significantly more secure than the original standard image. So here is, as we have seen, that we'll see a hardened virtual server image is a template for virtual server service instance creation that has been subjected to a hardening process. So this figure shows the hardening process. Here is the security policies, and then you have virtual server image here. Hardened virtual server image is obtained from a virtual server image. So how this is done, and ultimately here what you have is the resource management system, VIM and VM image repository. So security policies, so what you do is close unused or unnecessary server ports. This is what all we do. Disable unused or unnecessary services, disable unnecessary internal root accounts, disable guest access to system directories, uninstall redundant software, establish memory codes. So a cloud provider applies its security policies to harden its standard virtual server images. A cloud provider applies its security policies. So all these are, policies are applied to harden its standard virtual server images. The hardened image template is saved in the VM images repository. So here we store it in the VM image repository as a part of a resource management system. So this is the overall hardening process. Hardened virtual server images help counter the denial of service, insufficient authorization, and overlapping trust boundaries 3-8. So this is how it is so much of useful, that it helps counter the denial of service attack and insufficient authorization attack and overlapping trust boundaries 3-8, because so many cloud consumers are there. They are sharing their trust boundaries with the cloud service providers, with among the other peers. So all these problems are being overcome with a hardened virtual server image. So it helps in counteracting with all these attacks. The cloud resource administrator chooses the hardened virtual server image among hardened virtual server image option for the virtual servers provisioned for cloud based security group B. So here we can see that this is a cloud resource administrator, and this is the usage and administrator portal. This is resource management system where VM image repositories stored, hardened virtual server images are stored, and here we can see that these are all hardened virtual servers of cloud-based security group B. Cloud-based security group A is shown here, and cloud-based security group C is used here. So this is how the hardened virtual server images, they help counter the denial of service, insufficient authorization, and overlapping trust boundaries 3-8. Thank you.